Hello, thank you for being here, for watching this presentation at Coding Bootcamp 2023. And my name is Wagner Landgraf, and I'm going to talk about OAuth 2, a way to authenticate web, mobile, and desktop applications safely from a single server. As I say, my name is Wagner Landgraf. I work with the Delphi community for more than 20 years, since, I don't know, 1997. I believe it's 25 years. I'm not counting anymore. And I'm the author of many Delphi libraries like TMS Aurelius and ORM, TMS Xdata, Amazon Web Service SDK. And I'm mostly involved with the two entities, which is the great TMS software, a software vendor for Delphi libraries and components, and my personal website, landgraf.dev. Shall we start with some stories? Once upon a time, computers appeared. They occupied big rooms. Their memory couldn't hold much more than some texts. At the time, probably securing a computer would be a matter of having a padlock to prevent people to enter the room and have access to the computer. I'm not going to enter into the details of corporate computing at those times because I'm not old enough to have witnessed it, so I don't know exactly how it worked, but we know that with personal computers, the story was the same. Is the same. We had our computers at home and we didn't care about securing them too much. It only started to make more sense to secure them, to add a password to it when a computer was being shared with other people. So each user will have their own account. So you enter in the computer with your account, your colleague also, so you have different data. But all that changed dramatically when networking and the internet appeared. And again, we can make the same analogy of personal computers with software applications. In the past, we usually begin to protect our applications when they become multi-user, for example. One popular application architecture not so long ago was the client-server paradigm. We have we had and we still have one database server, then multiple desktop clients. Those desktop clients are usually Windows executable applications, especially if you work with Delphi, if you build those applications with Delphi. And those applications were connecting to the database directly and manipulating data. Probably you have built and maintained such kinds of applications. And what was one common way to protect it that probably you are using it? You have a table in your database of usernames and passwords or hashes of passwords. And you simply check if the typed username and password match what's saved in the database. If the username and password typed by the user in your desktop application matches the database, your desktop application continues and shows some form with user data. It's just application logic. You have in your desktop application logic, if username and password fails, don't continue, ask the application, the credentials again. And even when the first common web applications appeared, it was still possible and relatively secure to use such approach. The web applications were generated fully server-side. So the user went to the browser, typed username and password, and those credentials were provided to the server. The server checked them comparing what's there in the database, and then returned the full rendered HTML page to the client with maybe a session token, always safe, always server side for further operations. For example, if the user clicked a link, a new request was made sending the session token. It was up to the server to control everything. If the session was still valid, who was the user of the session, and then return again another HTML page. But times changed. Applications are now distributed. Actually, maybe you can say that an application is a collection of applications. your full application might consist of a desktop Windows application, maybe a legacy desktop Windows application where most of the heavy operations and data input is made. But that might also, your full application might also consist of an additional web application where reports and data can be provided to a wider audience. It might also consist of mobile applications that receive notifications or you can use to quickly upload data, a photo or an audio to the central server. And even the web application is now running in the browser like a desktop application, not rendered server-side anymore. There are not only server-side web applications built with PHP, ASP, or Java, but also client-side JavaScript web applications built with React, Angular, and TMS Web Core. And all of those, the set of the desktop, mobile, and web applications is your full application. And probably all those parts of your application are being used by a single user. You know that by now as a user. We use those kind of applications: Facebook, Instagram, Twitter, your local gym application, some government services that you access from web or mobile. We use all those either from our mobile phones, from our computers, using our internet browsers, and some of them even have downloadable clients so you can install in our computers. But there are more news. The server part is also now distributed. There might have a specific server that is built and used just to respond to the mobile applications, another one for the web applications. Maybe there is a third server that is not directly called by the applications, but by those two servers are mentioned before. So in this complex scenario, if you are building such kinds of applications, how to protect them? You might be tempted to keep using your username and password approach. But then you have multiple servers. Some of them don't even talk to a database, but another server. So how are you going to send and receive back the username and password through all those things in a secure way? And now the username and password has to be saved in the mobile or web application because you don't want to ask the user for username and password all the time. And what if that password is stolen? It's now easier to steal that password from a browser or from a mobile application. And the first thing you'll be tempted to do is to roll out your own solution. Maybe you can save the password encrypted in a mobile app. Maybe you can save some temporary code in the mobile application and check it against the server. And then you start finding solutions, and then you think, well, but if someone steals this, no, then I have to set a new flag here and there. And my answer to you is one of the first advices experts give about security: avoid reinventing the wheel. Someone already thought that for you, and you should search for a solution. And what is that solution? OAuth, and one of its extensions, which is OpenID Connect. OAuth is not the only solution, of course, but it's widely adopted. If you Google for how to secure your API applications, you see many sites recommend use OAuth, consider OAuth, because it's a flow, it's a workflow. All those bits and pieces are already thought of. When you see that button, log in with Google, log in with Facebook, that's OAuth in action. So what is OAuth exactly, and how does it work? Well, if I'm going to just read for you a formal definition, OAuth is short for Open Authorization, and it's an open standard for access delegation, commonly used as a way for internet users to grant websites or applications access to their information on other websites, but without giving them the passwords. It's interesting to see this notes that access delegation and the word authorization. That's the original problem that OAuth aimed to solve. if you think about how systems were integrated before OAuth, for example, how would it work? For example, you have one application, you are the user of one application, and that application wants to communicate with a third-party application. For example, want access your photos stored in Google Drive, in your Yahoo service. Remember Yahoo? So how does your application, how do you integrate your application with Google Drive, for example? Before OAuth, your application has to ask the user, hey, give me your username and password of your Google Drive account. This way I can access your photos. The problem with that approach is that the application will have full access to your full Google account. And you have to give him all the credentials. And with the credentials, you have full access. The application could delete your photos, could even change your password. Who knows what he would be doing. So that's the problem that OAuth solves. It's a way to give access to another application without providing the user and password. And this is how it works. This is more or less, this is abstract flow. OAuth has these flows, which is the workflow. Remember about reinventing the wheel? A flow is what the OAuth engineers talk of about how to protect things and give access and save stuff without compromising too much. So the idea is that you have the client, which is the application that is trying to access Google Drive, for example. And you have the resource server in blue, which is the Google Drive application. And you have the middle layer here, which is the green authorization server, which is the server who is dealing with OAuth. So the client, first thing, the client asks the user, you, to access Google Drive. At that point, you go to Google, log into Google, and Google asks you, hey, do you want to give access to the client for your Google Drive photos? Then you say yes. Then the authorization grant goes back to the application too. And then with that information, with that kind of credentials provided by Google, you go to the authorization server and get an access token. And then with that access token, the application can go to the photos and get the photos. But the idea here is that you probably have seen it. The OAuth server, in the step 1 there, authorization requests, the OAuth server tells you, hey, the client is trying to access your Google photos. Only read-only access to your Google photos. Do you want to give it to them? So that's how it works. The flow has scopes, has permissions, so the client will only access your photos with that access token that only gives them that specific permission of read your photos. And then remember I said that OAuth has its flows. Those are grant types of flows, are ways to get that access token or get the authorization to access a server, but depending on what kind of application you use. OAuth uses it to have many grant types: the client credentials flow, the implicit flow, the user and password flow, the code authorization code flow, and lots of flows. And many of them, I don't know the exact history of OAuth, but I believe many of them were being created or spin it off from the original ones, depending on the kind of applications that appeared. For example, the client credentials flow is the simplest one. It's targeted to machine applications. There is no user. So you have a server and you have to access a third-party server. That's fine. But then you have web applications using PHP, for example. Then you have authorization code. But then it started to have desktop applications or JavaScript applications. Then you have the implicit flow and so on. So you should tell which flow you are going to use depending on the application that you are going to build. Luckily, OAuth 2.1, it was kind of simplified. So this is not a comprehensive rule, but in general, you can just use two flows now: the client credentials flow for machine-to-machine applications and the authorization code with PKey, which is proof of key for code exchange, and that can be used safely for server-side web applications, single-page web applications, and native applications. Now, before I continue, let me go back here to the screen to reinforce the key concepts of OAuth. There are 4 entities here that you see in the page that I mentioned, but I will strengthen it. There is the resource owner, which is the user. There is the authorization server, which is the central server who issue tokens and check for the grants, etc. There is the resource server, which is what we want to access, Google Photos or an API. And then there is the client, which is the application trying to access something. That client is called also the application for OAuth. And you see that usually in practice, you have the client. A client can be your web application. A second client can be your desktop application. A third client can be your server accessing another server. So for each of those clients, you use a specific flow. And each of those clients has to be known by the authorization server. That's why, for example, when you go to Google, if you have checked it, you can see, hey, I need to create an application that you have access to Google Photos of the user. So you have to register your application on Google saying, this is my application. You have lots of IDs and things like that. And that will be a registered client for Google. Let me try to illustrate OAuth here. It's a little bit complex, the details, but I try to illustrate how it looks like with this nice OAuth 2.0 Playground, which is a web page that simulates a real OAuth communication. Here you have the playground. The address is, the URL is oauth.com/playground. And we start with a flow. So let's use, for example, the authorization code, which is the same as the one using proof of key, but this is more simplified, so it's easier to start with. And it's one common one. It says, to begin, register a client and a user. All right. This is exactly, the user is just to simulate that we have a user in the OAuth Server application. So suppose this is a Google user or a user in your application, in your OAuth application. And the client registration is not used in authorization code, but it's created here. But remember that the client is the application. We are simulating your web application here. Anyway, let's go on and try the authorization code. So this is the idea. Your web application or your web server web application, anyway, the application trying to get access will build a request, an HTTP request to the authorization server, to Google, for example, or to the, suppose you have created your authorization server. So this is the URL of the authorization server. And then you have these parameters which are specified by the OAuth standard. You see that this is the flow. We're specifying that we want the code flow. We are specifying the client ID, which is my application. Hey, I'm the application web, my web. And this is the scope, which are the permissions that you want. So you want to access photos and offline access. This is defined by the application, by the resource server itself. For example, if you are going to access Google Photos, it's Google Photos that is specifying the scopes that it will accept. And state is a random string generated by the web application. And finally, we are going to specify a redirect URL, which will be called by the authentication, the authorization server, after all is done, because now we are going to be redirected. The web application is calling this, and the authorization server will try to log in the user and ask the user permission. When all is done, it will come back to the redirect URL. So let's authorize. And now the web application goes to OAuth Server. It's the OAuth Server. For example, again, it's Google. If the authorization server will be Google, we will say here, log into Google or log in, confirm this is your account. If this is your server, it will be you asking for username and password for a list of users you might have. So we have saved the information here just for, we are simulating that we are logging in as a user. And then the OAuth server asks, hey, the application OAuth Playground, remember that's the client ID, would like to access your photos. Approve. And then it calls that redirect URL with the information. This is the information passed back to your web application. The authorization server is passing back the state and some magic code. You will check the state to see if the state matches of the one you generated, because otherwise there might be some attack here if the state is different, someone trying to steal. So make sure the state is the same. So if it matches, continue. And now with the code and the state confirmed, your web application goes back to the authorization server in a different URL named token, saying the grant type is authorization code, the client ID is this, the client secret should not be used for public web applications. This is a tweak. And again, the redirect URL and the magic code. Once we do that, now we receive an AJAX response. It's not redirected now. The authorization server finally answers with the final answer. Sorry for the redundancy. Saying that, okay, here are your credentials. The token type, how long will the token last in seconds, in milliseconds, in seconds, and the scope that you asked for. Sometimes it's different. Sometimes the user allows you only to have one of the required scopes. And finally, the access token. This is the token that you are going to use, your web application is going to use from now on to access the photos, all right? And this is the authorization code flow. I'm not going to, there's no time to enter into details of all the flows, all the details here about the parameters. The OAuth has a lot of, there are specification about the error messages. But the idea, I hope you get the idea of the flow, because you can use this for authorization and also for authentication if you use OpenID on top of it. But you notice that the same approach with OpenID can be used. This access token, for example, is the token that you are going to use to access the server. The server can be a resource server like Google Photos, or it can be your own API server. So this is the OAuth flow. Following this standard, you can either create an OAuth client, like this web application does, which you can use to log in to Google, for example, or you can build an OAuth server that you can use to provide access to users. My point here, one of my points here, is that you see that the flow has lots of checks here about the state, checking the state, generating a code. And if you go to the proof of key with code exchange proof key for code exchange flow, which is a slightly different flow from the one we saw, you see that the client should generate a code here and send that part of the challenge to the server, and then the flows continue. All of this was thought to because to avoid attacks. For example, this, of course, during the process of building this flow, I can imagine that the engineers were thinking, okay, what if an attacker does this? What if an attacker does that? What if it changes, if it intercepts the URL and try to change the code or try to impersonate something? So all of these codes and exchanges and things like that were already thought for you in advance. So in theory, if you're using a standard way of doing things, you don't have to think too much. You always have to think, of course, but you don't have to think too much about the holes in your process. What if this? What if? This was already thought of, so you can follow the standard to have a little more peace of mind, and of course you have more integration with other systems, because since this is a standard, if you have an OAuth server, for example, you can say, hey, my server is OAuth compliant. You can use it to access my application if I want to. That's a common flow. Okay, now that we talked about what is OAuth, how to use it as a developer. For several languages, we have libraries that allows you to create. Actually, most libraries are more for client side of OAuth, but you also might need server-side OAuth. There are some libraries here and there. For example, for .NET, there is the Duend software, which is the old Microsoft Identity Server, which is now Duend Identity Server or something like that, which is a paid library. And you also have some open source servers like Keycloak, but you have to, I think it's made in Java, and you have to install the server and know how to use it, of course. And you have services, cloud services for that. The most famous one is Auth0, for example, which is you have a full OAuth server ready to use, but then it can become very expensive as your application escalates. As many services, they charge it by user, by lots of metrics. One of them is number of users, for example. And the problem with cloud services is that it's harder to integrate with your existing applications. And if we talk about Delphi, which is our favorite development tool, you have, of course, you can read the standard and try to implement it yourself. But we have the option of using TMS Sphinx, which is a library from TMS software that provides you with OAuth client and server capabilities. So TMS Sphinx is a way for you to create single sign-on servers with Delphi using OAuth standards. It's similar to, just for you to understand, if you know Identity Server, Auth0, it's similar. It's a way for you to set up and create a server. The difference is that it will be a server written in Delphi that you have full control of source code. So of course you can deploy whenever you want to deploy it, and you can customize and integrate with your applications. It's OAuth is compliant. It uses some ideas of OpenID Connect. And the point is that you have a solution that it's standard using OAuth. It's interoperable. It's because of that, it's future-proof and it's secure. And some of the features of TMS Sphinx is that you have a users database, you have access control, you have all this OAuth flow that you saw implemented, and you have also the login page, all the user interface for that with the new user registration, email confirmation, multi-language, and features like password reset. So it's not only the OAuth flow per se, but all the infrastructure that you need around to really create a single sign-on application with all the going from the database with the data to the web user interface, and of course, since it's Delphi, with the ability of integrating with your existing users database, for example, to use your favorite database server, your favorite database access components, and you have the freedom of building your OAuth server the way you want, and of course the costs for deployment and infrastructure will be lower as well. So let me try to give you an example of how TMS Sphinx works. There will be, of course, no time to build one server from scratch or explaining every detail. So I will start with the existing demo application for TMS Sphinx that is distributed with the trial. You can download the installer of the free version, of the trial version, and run it for yourself. But the idea is that you have an API server, a web client, and a desktop client, and then show how to integrate everything. First of all, let me show you what this demo does. So we have an API server here, which is the application, right? There is no involvement with the authentication. It's just my application. And then we have this Sphinx server, which is the authorization application. And then we have, for example, a VCL client, which is the client application that will connect to the database. We connect to the application. So we have this check login status, user is not logged in. I will log in. It opens a browser to log in. It's important to mention here that you can open this login page inside your VCL application. It's possible, it's technically possible, but it's not recommended in terms of security, because this way the user can see the browser. There's lots of security implications, and one of them is that this way the user makes sure that it's going to a valid page. Of course, this is a test, but it will be your certificate here, your URL. So even Google, for example, recommends that you don't open the login page from inside the application, but instead use the default browser of the mobile or the operating system. So after I log in, the application is closed and the user is logged in, and this is a multi-tenant demo. It just shows the albums for Hans, which is the user logged in here. Okay, if you see that if I log with a different user, for example Mike, you see that there is this And Justice for All album here. If I log with a different user, there is a different list of the albums, right? So to explain here, we have 3 different applications here. We have the client application is a regular desktop VCL application, which is taking the album list from the API, from the application itself. It's just that the application rejects any request that doesn't have a token there, and that token must be generated by some valid authorization server. The point here, the OAuth gets into action when I click login. Then I call the authorization server to do the OAuth process of authorization. And then it opens, the authorization server opens the web page, logs in with the user. Everything is being done by the authorization server. Logs in, checks for the user password. You saw that there is a forgot password. If optionally you can make the user register an account if you give that option. And then after all is done, the authorization server, the browser, goes back to the client here. The client is listening for a response, and then the response comes after all the OAuth flow finishes. The response comes with the user logging in, with access token, with ID token, all the information that is needed for the auth. And then with this access token, for example, the client application can finally call the API application authenticated and authorize it with the permissions that, with the limited permissions, and the authorization server is not in action anymore. So this is a single sign-on application. You have an authorization server that serves tokens and logs in users for different applications. There is also a web client here, which is a web version of a simplified web version of the VCL application, just to show that the process is the same for web. So if I log in, I log out here. If I log in, it goes to the same web page. So now I'm logging to the web application. So using the same username and password, is still the authorization server here. After all the login is done, it goes back to the web application, which has nothing to do with the authorization server. So the point here is that you have four different applications here. You have the API server, you have the authorization server, you have the desktop client application, you have the web application, and you might have mobile applications, and everything is being, all the authentication and authorization and permissions are being managed by the OAuth server, and the application is built almost without knowledge of and requirement of knowing the user names or tables and passwords and things like that. It's just a matter of receiving tokens with permissions and accepting them. So let's see how, more or less quickly, how the code is structured here. I will not spend much time in the API server. It's just the application. It's built with Xdata, but you can build it in any language, any framework, Delphi framework you want, data snap, and even you can be written in a different language. It doesn't matter. All that it matters here is that since it's Xdata, you have this JSON Web Token here, that it's a Xdata server. It checks for JSON Web Token and translates the scopes to authorization, and it has a specific mechanism for authorization with using attributes. But if you're developing with a different framework or language, you just have to check for JSON Web Tokens, check if the request is coming with JSON Web Token, and if the content of JSON Web Token is valid. We didn't have time to cover JSON Web Tokens here, but you can find it online. It's just a token that gives access, contains valid information for access applications. And then we have the VCL client here, which is also just using that token to call the API. If you go, for example, to the code that asks for albums, it's also using Xdata client, get albums, but you can use HTTP raw HTTP requests. The important part is this, is that when requesting the API server, if there is a token, then it includes the token in the request. So if the user is not, the way to check if the user is logged in is just to check if there is a token. Because if there is not a token, you cannot call the API server. You can, but you get your requests rejected. So once you log in, we saw that the server gives you a token. With that token, from now on, you just call the API, your business API or application API, passing that token. And the Sphinx part here is the Sphinx login component. Here you specify the URL of the authorization server, the Sphinx server, which is running locally here in the URL /tms/Sphinx, and the client ID. Remember that we have clients, applications in the OAuth standard. Here's the desktop client, and the scopes we want to ask. Sphinx makes it easy because once you have that configured, you just call Sphinx login, and it does all the process of launching the browser, waiting for the authorization server, for the login process to come, and then when it's finished, we have this event on user logged in. That is a callback when the login process is concluded, and then we can save our token and use the token actually to load the albums for the users. So this is the client in the application. And finally, all this is orchestrated, is made possible with the Sphinx server, which is also not very complicated. We have here some components. Since Sphinx creates and updates its own database, its own tables in your favorite database, if you're using MySQL or Postgres, it will create the user tables and password tables, the tables for the users, passwords, roles, etc. in your favorite database. So most of these components are for that, for the database connection, for the connection pool, etc. But the important part is the Sphinx config and the Sphinx server. The Sphinx server is where configures where the server will run, the URL and the database connections. And the Sphinx config is the most important part of the component. And you see that code is simple, it's just less than 200 lines of code. The most important part is here, where you configure the clients. You saw that we have a client named desktop. So here I'm telling Sphinx what are the applications that are going to connect to my server. So this is OAuth. It's pure OAuth. You have the allowed authorization flows that you want. So I'm going to use authorization code, the redirect URLs, the display name of application, the scopes that I'm going to allow. Remember the OpenID email, and here is for the web application. And that's mostly it. Of course, you have lots of small configurations here, as I said, for the database, for the language of the application, some customization. And here I have some integration. Here's an example of integration with my application. Here I'm creating the users manually here, but of course, in a more complex application, you can integrate, if you want, your users to get the valid users and passwords from your existing database. So you see that the username and password might still exist, but the difference that the user from that mobile, from the web application, is not going to keep using the username and password all the time. It use it to log into a central server, which is the OAuth server created by Sphinx, and then from that it will use the proven mechanisms of getting tokens and things like that. Okay, we don't have much time here to cover the details. It's just for you to see that it's rather simple with a few lines of codes to create an OAuth server with TMS Sphinx, and how it works in a real application, real demo application with the API server, how it interacts, how OAuth orchestrates this authorization and authentication with the Sphinx server, the API server, and the VCL client and the web client. And you, of course, also can have a mobile client here using the same process. Thank you for watching. I'm open to answer all your questions you might have.
Well, that was an excellent session. Wagner is one of those guys. I know a lot of developers and I meet a lot of developers. And Wagner is in my list of people I seriously admire because he's a very, very smart guy. I use actually his products in my own coding. You know, they're very, very useful. He's doing all sorts of things. We're just sending messages to him now because he is going to join us live for the questions and answers. He's just working out the camera and the audio, I think. Let's see what happens. Wagner, are you there? I feel like I'm holding a seance. Like Jumanji or something like that. He's going to turn his camera on in a moment. Okay, well, Wagner, as soon as you've sorted that out, and Martha, can you make that happen as well in the background? I pinned some of the questions. Oh, he says he can't do anything. Okay. Well, look, I'll tell you what, I'll read out the questions and you can type some of the answers in the chat, our little chat window there, if you can't make the camera audio work. I'm not being able to turn on camera or audio. Oh, I see. He says he can't do it. I think he's just disappeared. He's gonna... There we go. I think it's turned on now. There you go. Ha ha. I knew we'd get you eventually.
I
How
had
are
to
you
do the
doing?
old trick of closing and open the browser again.
Yeah. Try turning it off and on again. That's exactly how it always works, doesn't it? Your session's very, very popular, and as I've said before, I actually personally use some of your stuff, and Sphinx. I've had a look at it and do some. I'm working on a project, my own, project, not Embarcadero stuff, that uses WebCore, of course, which you also have a hand in, and Xdata and Aurelius in the background. So that's not what we're talking about now, but I've got a lot. Yeah, what can I say? I mean, I keep saying this before people say, "Oh, you talk about TMS a lot." Well, if they stop creating good products, then I won't talk about them. It's as easy as that. So your session had a lot of really positive comments, and I thought I'd pick on a few for you. Apart from this one, which is actually not about this session, but I'll just put it up anyway. Excuse me. Someone saying they're looking for someone to take them on as a student. So if you're out there and you're on YouTube, Ayokanmi Agbula is looking for someone to kind of mentor them. So please feel free to go on YouTube and say hi. And if you feel like helping he or she out, I'm not quite sure what gender their name is, but go ahead and message them up. Anyway, so someone, I don't know what the answer here is. I did nip out and get some coffee at one point. Is there access to the code examples at all, Wagner?
Yeah, sure. Actually, there's it's in TMS Sphinx. So if you download TMS Sphinx, there is the full demo there with that I use it, the existing demo.
Yeah. Okay. Well, what I'm going to do is don't worry about that. There's always someone in the background at every time we go live, and they always wait until we go live. Let me just pull this up. So I believe if I put this up here.
Yeah, I know that it's a complex topic actually. I all these distributed systems, it's hard to. I had myself hard time in the last years, of course, when I was learning all about this. Because as I introduced in the beginning, now that everything is distributed, you have Facebook and you can log into Facebook from your mobile or your web application, and I see many people struggle with it on how to authenticate if they want to go to that direction. And unfortunately, I'm not a teacher like Alistair, Christie, or Holger Flick. So it's hard for me to explain things, and this is a complex topic actually. At least I myself had a problem understanding in the beginning. But
yeah, I mean, it's OAuth is one of those things where when you need it, you really need it, and then you've got to try and understand how it works. And the big hurdle is learning how the thing works behind the scenes. And then once it all falls into place, then you've actually got to make it happen. And so it is a big hurdle. But I think Sphinx makes it a lot easier, I have to say. I understood your example, but perhaps I've got an advantage because I've written some systems before. Another question that came up, let me just find this. This was from Patrick Prematar, who is our MVP, who's answering a lot of questions today in the chat and is going to be here all week because he's crazy and has no life, clearly. But he said, do you activate a personal SSL certificate for the OAuth, or does it work in HTTP? And you did answer, but I thought we'd just pick that one up again.
Yeah, that's a very nice question because it relates to the question from Lina that she also asked a similar question there, because in the OAuth communication, for example, when you say log in with Google or access my Google Photos, you have to go to Google, your browser goes to Google, and after Google or Facebook or GitHub or whatever does all the authentication and authorization for your user, it has to go back to your application to tell your application, hey, your user is authorized. If your application is a server application, that is easy. But in this case, it's a VCL application. So how does Google go back to your local VCL application? So it's a local server that it's run inside the VCL application. And it's the same for a mobile application, for example. It's a local server or a URL that goes back to to your client application. There is no communication. Of course, Google doesn't go. It's not Google that communicates with your VCL application. It's just the browser where you're running the Google website. It goes to HTTP/localhost. So your browser just calls the small server that is running in your VCL application. That's how you get feedback from the authorization.
Yeah, and actually that's one of the things I think is probably the biggest hurdle for learning for most people, is that actually there's an active connection between your app and something out in the internet or out in the world to enable that conversation to go on. It's not just like you're calling an API and then you get a response. No, it actually sends some information down. So it's a bit more of an active connection than just, pinging some web page and expecting a HTTP 200 or something. No, there's a conversation that goes on. And in fact, Lena was the person that asked about that. She said she had to call an API for a tax authority, and they needed to use OAuth. And she was saying, well, why have they maybe create a server? And that's exactly what you explained there. The server is there to get the response from that OAuth endpoint and hold that conversation that says, who are you? Prove who you are. Here's a package. You do some more response, and then we're all happy, and then the server is off and closes. So it's a bit more complicated than a lot of people think. That's it. What is we're getting a blip come up, so I think that means someone asked some question here. Let's just see what they've said. Oh dear. Okay, so that the new person who's looking for help says nothing is making any sense. Don't worry. For the next 20 years of your programming career, you will feel like that every single day. Don't worry about it. Not understanding what's going on is 90% of a programmer's job, I think, is why is this not working? And then, oh, now it's working. Why is it working? It's
working.
Amazing. Yeah. So it's good stuff. So the Sphinx suite, is that sold separately by TMS, or is that actually just on its part of a package?
It's in the TMS package because it needs to use all those other packages to work properly, because you have to creates your database with users and roles, and so it uses arrays, it's run over Xdata, so it doesn't make sense to. It's part of the package. Actually, that's a complement to Xdata. For example, if you want to build a REST API server with Delphi and Xdata, then it plugs in. It can be used separately, but it's a way to easily authenticate and authorize.
The system I'm working with has got Xdata, and then there is an OAuth in the background, but it's a kind of weird, not my fault, we're calling some API that someone else has provided, but they do a licensing authorization. That's why they have it. It's not just the users, but actual whether the person is entitled to use this entire package, and we use OAuth for that, a kind of OAuth. So there you go. And Xdata, yeah, it's great. Where can I find, this is a question, where can I find code to make a server inside my app so I don't need to set up a web page for my app to download a text file? Oh, this is a TRNOD who earlier on said, I want to be able to download files secretly so the user doesn't know. And I said, what computer virus are you creating there? Because you're describing the behavior of computer virus. But they did go on and say it's because they show messages in their program.
I follow it. I followed the conversation. If I don't know if it's he or she, but if you don't want to have a server, you have to use a cloud services like Google Drive or something like that. But as someone said, that it's actually a little bit more complicated to upload and download a file to a cloud service like Google Drive than to have your own server. Because you have to go actually through all this, what I show it here from client side. You have to ask for authorization, get some tokens, scope, etc. If you have a website with PHP or with Delphi, you can it's easier to upload and download a file.
To be honest, most hosting now for a very, very small site, something like DigitalOcean or something like that, is so cheap that actually there's no reason why you would use a cloud service for hosting files. it would be much more efficient to have your website host that file and download it that way. And in fact, as a developer, if I was answering the question that they were asking, I would say, well, store it as a HTML file. And then you just pull down that HTML file and display it in a browser window built into your app, and then you've got full control over what you show in there.
But actually, Delphi has this native S3, Amazon S3 components.
Right.
I'm not sure if it has for Google Drive or something like that. But for S3, Amazon S3, you can try the native components and upload the file there.
Yeah, and actually, we've got a session on that. That's from Appercept, who does that, Richard Hatherall. And in fact, later on today, on my Space Computer demo, I'm just watching the time, I actually use those components, but to talk to AWS Poly, which is a AI voice generation thing, but the same components actually talk to S3. I've used S3 myself for some things. It's a little bit scary because, you know, there's buckets, and if you get it wrong, then you can accidentally expose some data to the world. And 9 times out of 10, when there's been some kind of data breach, it's because someone had a misconfigured Amazon server, because they're not very easy to understand, in my opinion. I prefer a plain old web server that I know how it works. You know, I know where it lives as well. It's not in the cloud somewhere. With OAuth, actually, just to talk about cloud services for a second, because this is my own personal experience of trying to make something work with OneDrive. OneDrive changed the way that API worked recently, and it actually is much more complicated, even though they said they made it easier. And most components that I found out there to work with OneDrive did not work with the way they changed the system. So G Drive or Google Drive is a lot easier. But OneDrive, just, I don't know, they said they made it easier, but I think what they did was made it easier if you're a Microsoft application, you know, because when I tried it with everything I could download, I tried a number of different OneDrive components, and none of them could work.
It's not exactly, I don't think they consider themselves as a storage API like S3. Is more like a service that they want you to subscribe to.
That's exactly the point. Yes, I hadn't thought of that. That's really what they're doing. They're trying to sell you their subscription service. Yeah. And people are saying there's a Delphi component for OAuth 2, but it doesn't have a way of listening for the HTTP callback. This can be done with, well, actually, Dave Green is saying that, and you're actually, you know, Wagner has just shown a component that does everything you need. So, and it does listen.
I think he's talking about the native one, about OAuth in Delphi.
Yeah, well, they could use, they could use your components instead, and they're not exactly expensive. You know, I think that if you're producing an app, the investment in the components is worth it. You know, it depends on how.
The difference here is that TMS Sphinx is also mainly for the server side, for you to create your application and allow login. That's not available in the OAuth 2 component for Delphi. That's one difference. So there's the client and the server. The OAuth one in Delphi is just for the client to connect to.
Right, yeah. And in fact, you know, if you're going to get it, there's a few different options as well, I'm sure. So it's interesting stuff. Okay, well, we're running short of time. I appreciate you. I'm not sure what time zone you're in. I think you're not that different.
3 p.m.
3 p.m. Okay, 2 hours ahead of me. It's 1 p.m. for me here. So not so bad as Alistair. It was like 3 a.m. for him. So, okay, well, it's always good to talk to you. I really appreciate your sessions. You are an incredibly smart programmer. You know, I've personally learned things from you, and I don't think I'm a slouch at programming, but I always say, hey, I'm just average. I just talk a lot. But, you know, I really appreciate it. You are one of the people out there who I actually admire for your coding skills. So it's good to have you on these sessions and to share the knowledge that you've got as well. So I really appreciate it.
Okay. Thank you very much. It's an honor. It's a pleasure to be here with you.
No problem.
And thanks for the opportunity. Thank you, everyone.
Welcome. All right.